Hello and welcome to our lesson on enlargements in geometry. Today, we will explore some important concepts that will expand your understanding of transformations and improve your problem-solving skills. In this lesson, our primary focus will be on understanding the concept of enlargement in geometry. We will define what an enlargement is and discuss its fundamental principles. Introduce the concept of a scale factor and explain its role in determining the size of an enlargement. Learn how to draw an enlargement using a given scale factor. And finally, apply these concepts through various examples to solidify your understanding and practice using these skills. So far, we have covered several key transformations in geometry, including rotations, reflections, and translations. These concepts have allowed us to manipulate shapes and understand how they can change position and orientation while retaining their basic properties. Building on this foundation, we can now introduce the concept of enlargement. This technique is crucial for understanding how shapes can change size while preserving their proportions and overall form. For instance, if we wanted to enlarge a small triangle to fit a larger space while maintaining its shape, we would need to apply a scale factor to each of its dimensions. This mathematical tool not only helps in geometric problems but also has practical applications in fields like architecture and art. Let's dive into the fascinating world of enlargements and see how this new knowledge can enhance your mathematical toolkit. Enlargement is a fundamental transformation in geometry that alters the size of a figure without changing its shape. This ensures that every angle and the proportionality of the sides remain the same. There are two key values that uniquely identify an enlargement transformation. Those are the center of enlargement and the scale factor. The center of enlargement is a fixed point from which all points of the original figure are scaled. It's the point you use as a reference to stretch or contract the figure. For instance, if you think of shining a flashlight from a point, the light rays spread out. Similarly, the figure enlarges from the center. The scale factor is the ratio that determines how much each length in the original figure is multiplied to get the corresponding length in the new enlarged figure. If the scale factor is 1, the figure remains the same size. If the scale factor is greater than 1, the figure enlarges. In this lesson, we'll consider scale factors greater than 1. Later on, we will look at scale factors less than 1. As an example, if a triangle has sides 2 centimeters, 3 centimeters, and 4 centimeters and is enlarged by a scale factor of 2, the new triangle will have sides 4 centimeters, 6 centimeters, and 8 centimeters because each side length is multiplied by the scale factor of 2. We will now look at how to draw an enlargement. First, label the center of enlargement on your grid. Then, using a ruler, draw straight lines from the center of enlargement through each vertex of the original figure. These lines will guide where the vertices of the enlarged figure will be. Now count the number of units moved horizontally and vertically. Multiply these by the scale factor 2 to get the new enlarged horizontal and vertical distance. Mark points at the new distances from the center of enlargement. Once you have marked all the new vertices, connect them properly to form the enlarged figure. Let's now illustrate this with an example using a triangle. Imagine a triangle ABC with vertices at A, 1, 1, B, 2, 1, and C, 1, 3, and a center of enlargement at the origin, 0, 0, with a scale factor of 2. We start by drawing lines from the origin, 0, 0, through each vertex A, B, and C. Next, we measure the horizontal and vertical distance from the origin to each vertex. Vertex A is 1 unit horizontally and 1 unit vertically from the origin. Vertex B is 2 units horizontally and 1 unit vertically from the origin. Vertex C is 1 unit horizontally and 3 units vertically from the origin. The enlarged distance to A will be 2 units horizontally and 2 units vertically. Enlarged distance to B will be 4 units horizontally and 2 units vertically. Enlarged distance to C will be 2 units horizontally and 6 units vertically. So our new points are A' at 2, 2, B' at 4, 2, and C' at 2, 6. To finish off, connect points A, B, and C to form the enlarged triangle. When enlarging about the origin, you can just multiply the coordinates of each point by the scale factor, since the coordinates are precisely the horizontal and vertical distances from the center of enlargement if it is the origin. By following these steps and practicing on various shapes, you'll gain confidence in drawing enlargements and understanding the concept of scale factor and center of enlargement. This process is also used in numerous real-world applications such as art, for instance enlarging a sketch to a large mural. Design, such as a designer creating a large textile pattern by enlarging a detailed design onto fabric. Engineering, such as engineers on a construction site scaling up architectural plans to build a structure. And finally, mapping, when cartographers enlarge a detailed map from a small section to a larger area. We'll now move on to some more examples. Example 2. Let's consider a square with vertices at 1, 1, 1, 2, 2, 2, and 2, 1, and we want to enlarge it by a scale factor of 3, with the center of enlargement at the origin 0, 0. Since we are enlarging about the origin, we can just multiply the coordinates by the scale factor, 3. This gives us new coordinates. A prime is 3, 3, B prime is at 3, 6, C prime is at 6, 6, and D prime is at 6, 3. Finally, connect the points to get the enlarged square. Let's do a final example, one that is not about the origin. Consider a triangle with coordinates 2, 1, 3, 2, and 1, 3. We want to enlarge it by a scale factor of 2 about the center of enlargement, 1, 1. We calculate the horizontal and vertical distance from 1, 1 for each vertex and work out the coordinates of the enlarged triangle's vertices. Firstly, the distance from center, 1, 1 to A, is 1 horizontally. Therefore, the new vertex will be 2 units from 1, 1 horizontally, which will be A prime at 3, 1. Next, the distance from the center of enlargement, 1, 1 to B, is 2 horizontally and 1 vertically. Hence, B prime will be 4 horizontally and 2 vertically from 1, 1, which will be 5, 3. Finally, the distance from the center of enlargement, 1, 1 to C, is 2 vertically. So the new vertex will be 4 units upwards from 1, 1, which will mean C prime is at 1, 5. Finally, we draw the enlarged triangle. These examples illustrate how to approach different cases of enlargement with varying scale factors and centers of enlargement. Practice these steps to get comfortable with the concept of enlargement in geometry. In today's lesson, we explored the concept of enlargement in geometry, an important transformation that alters the size of a shape while preserving its proportions. We began by defining enlargement and understanding that it involves scaling a shape up or down from a fixed point known as the center of enlargement. Next, we introduced the idea of a scale factor, which determines how much the shape is enlarged or reduced. A scale factor greater than 1 enlarges the shape, which is what we focused on today. Following this, we discussed the steps to draw an enlargement. Locating the center of enlargement, measuring distances from this center to the vertices of the original shape, and then applying the scale factor to these distances to find the corresponding points of the enlarged shape. Finally, we practiced drawing enlargements to solidify our understanding. By mastering these concepts, you are now equipped to tackle various problems involving enlargements, whether in exams or real-world applications.